Welcome back, everyone, for another deep dive.
Yeah.
And today we're going to be looking at something really interesting in the world of AI image generation. Um,
Oh, okay.
it's called Visual AutoRegressive Modeling, or VAR for short.
Mm.
And it's really shaking things up. It's
Mm.
kind of challenging those diffusion models that have been all the rage lately,
Yeah.
like the ones that power stable diffusion.
Right, right.
Have you had a chance to look into this VAR approach yet?
Yeah, a little bit. A little bit. It's very cool.
Yeah, it's really fascinating. And one of the things that I find so intriguing is that it's actually drawing inspiration from large language models,
Really?
like, the GPT
Oh,
models
wow, yeah.
that are so good at generating text.
Yeah.
So instead of predicting the next word in a sentence, VAR is predicting entire visual maps at different scales.
I'm really curious to understand more about that.
Yeah, me too. So it's kind of like instead of building an image pixel by pixel, it's working with these bigger chunks of visual information.
Oh, okay. That's interesting.
Almost like assembling a puzzle from larger pieces.
Yeah, I like that analogy.
And this next scale prediction approach,
Mm-hmm.
I think it's what gives VAR the potential edge
Yeah.
in terms of speed and scalability,
Mm-hmm.
and even the ability to do things it hasn't been specifically trained to do, like image in-painting or out-painting, or even like image editing with just a simple prompt.
Oh, very cool.
So there's a lot to unpack here.
Yeah, definitely.
But before we dive into VAR, I think it would be helpful to kind of take a step back and revisit the world of traditional autoregressive models for image generation,
Okay. Yeah.
just to kind of set the stage. Can you remind us how those worked and why they kind of hit a wall?
Yeah, sure. So the old autoregressive models for images, they kind of tried to treat images like text. They would break down the image into these small tokens, kind of like think of them as pixels on steroids, right?
Yeah.
And then they would take the entire image and flatten it into a single line of these tokens, like you were taking a beautiful tapestry and just turning it into a single thread. And then the idea was to predict each token one by one, just like predicting the next word in a sentence.
Makes sense on the surface,
Mm-hmm.
but I have a feeling it wasn't that smooth.
Well, yeah, it kind of violated the nature of images.
Right.
Because unlike text, which flows in one direction, images have information that's connected in all directions.
Oh, yeah.
And so forcing this one-directional approach meant that the model was really struggling to capture the complex relationships between all the different parts of the image.
Right, right. So it's like trying to understand a symphony by only listening to like one instrument at a time.
Exactly. You'd miss the harmony, you'd miss the interplay between all the different parts.
Yeah.
And that's why they had problems with things like predicting the top half of an image if you only gave it the bottom half.
Right.
Because they couldn't really grasp that bi-directional nature of the information.
Yeah.
And then on top of that, flattening the image messed up the natural relationships between neighboring pixels,
Oh, yeah.
which led to a loss of detail, and just overall the coherence of the picture was just gone.
Yeah. So you're like scrambling the pieces of a jigsaw puzzle.
Yeah.
You lose the big picture because all the pieces aren't connected in a meaningful way anymore.
Exactly.
I'm also imagining that generating images token by token must have been incredibly slow, especially for high-res images.
Yeah, it was painfully slow, especially as resolutions got higher and higher. And that is where VAR comes in and swoops in with its innovative approach.
Uh-huh.
So instead of predicting each individual token, VAR focuses on predicting entire maps of tokens at different scales.
Mm-hmm.
So it's like starting with a rough sketch
Yeah.
and then gradually adding more and more detail until you have a complete masterpiece.
Oh, that's fascinating. It's like it mirrors the way that our brains perceive images too, right?
Yeah, we don't start with individual pixels. We see the overall composition and then we refine the details.
Exactly. And by working with these bigger chunks of information, it seems like VAR preserves those crucial spatial relationships that were lost in that old approach.
It does. It's a much more holistic way,
Right.
and frankly, just a more elegant way to tackle image generation.
Yeah, okay. I'm starting to see why everyone's making such a fuss about VAR. It's addressing these like fundamental limitations of the old way
Mm-hmm.
in a really clever way.
Yeah.
But I'm curious, like, how does it actually work in practice? Can you walk me through it?
Sure. Okay, so imagine you have like blueprints for a building, right?
Yeah.
But instead of having floor plans and elevations, you have these maps of visual tokens
Okay.
at different levels of detail.
Yep.
That's kind of how VAR approaches image generation. It starts with a very basic, low-resolution token map, like a rough outline of the image.
Right.
And it uses that as a foundation to then predict the next level of detail, a slightly higher resolution token map.
Okay.
And then that process repeats. Each new token map is predicted based on all the previous ones. And it gradually refines the image from these coarse scales to these fine scales.
It's so cool.
Like watching a sculptor starting with a block of clay and gradually shaving it into a masterpiece.
It really is. And
Yeah.
and this multi-scale approach,
Yeah.
it's not only like more intuitive, but it's also way more efficient.
Yeah.
Because by predicting these maps of tokens in parallel, VAR just significantly reduces the computational burden compared to that old token-by-token method.
Right. Exactly.
Yeah. Like, remember how we talked about those super long rendering times with the traditional models?
Yeah.
VAR can generate high-res images up to 20 times faster.
Huge difference.
That's crazy. So, okay, VAR is elegant, it's efficient, but does it actually deliver?
It does.
Like, what are the results telling us?
So the results are really impressive. VAR is producing high-quality images that are on par with or even surpass those generated by some of those big, powerful diffusion models like DIT, which is, the backbone of stable diffusion.
Right.
Better image quality, more diversity in the generated images, faster inference speed, basically winning on all fronts.
It sounds like it's really like shaking things up in the AI world.
It really is.
Yeah. So there's more though, right? Remember we were talking about those scaling laws with large language models?
Yes.
Where like bigger models just tend to perform better?
Yeah.
Well, it turns out VAR exhibits those same scaling laws.
Interesting.
As the model size increases, the performance improves in this very predictable way, just like we see with those language AI giants.
That's really interesting.
It's exciting, right? Because it means there's still so much untapped potential as researchers build these even larger models.
Right.
But before we get carried away with the future, let's take a minute to just appreciate what VAR can do right now.
Yeah, absolutely.
You mentioned some pretty cool applications earlier.
Yeah. Let's dive into some of those zero-shot generalization tasks
Okay.
that really showcase VAR's versatility. So, for example, imagine you have a photo and there's a big chunk missing, like someone took a bite out of it.
Okay.
VAR can seamlessly fill in those gaps.
Creating really realistic, contextually appropriate content. That's in-painting.
That's incredible.
Yeah.
Okay, what about outpainting? Like extending the image beyond its boundaries.
VAR can handle that too.
Really?
It can seamlessly expand the scene, add more background, even new elements that fit in with the style and composition. It's like having an AI artist that can extend your canvas and imagine what lies beyond the frame.
That's so wild. Okay, so what else can this AI artist do?
Well, let's talk about class conditional image editing.
Okay.
Imagine you have a photo of a cat, but you want to transform it into a dog.
Okay.
VR can actually do that. Realistically, change the image based on like a class label you give it, all while maintaining the context and the realism.
It's like having an AI Photoshop wizard at your fingertips.
And what's really mind-blowing is that VAR can do all of this without being specifically trained for these tasks.
Wow.
That's the power of zero-shot generalizations. It's like it has this innate understanding of visual concepts that lets it adapt to these new situations and challenges.
So as you were going through all this research, what stood out to you as the most surprising or impressive thing about VAR?
I think the thing that really impressed me the most was just the sheer speed and efficiency of this approach.
Yeah.
We've talked about how those older models were so slow, especially for those high-res images, but VAR just kind of breezes through it.
Right. It's like night and day.
That's like the difference between riding a bicycle and driving a sports car.
Exactly. And that kind of speed just unlocks so many possibilities.
Yeah.
Especially for real-time applications.
Right.
Like imagine interactive image editing where you can make changes and see the results instantly.
That would be amazing.
Or personalized ads that adapt to your interests on the fly. It's like the whole visual world is becoming as dynamic and responsive as like the digital world.
I can picture like personalized video games where the environments and characters like adapt to your choices in real time. It's like you're stepping into a world that's constantly evolving around you.
I know. It's incredible. And think about like education and training. Imagine these interactive simulations that respond to your actions and help you learn more effectively.
Right.
VAR could revolutionize how we learn.
So, okay, We've talked a lot about what VAR is and how it works.
Yeah.
But I think now it's time to address the why should I care question.
Yeah.
Like, what does all this mean for the average person?
Right.
Who's not an AI researcher or a tech enthusiast?
Well, I think it's important to remember that VAR isn't just this cool tech demo. It really has the power to transform how we create and consume content in our lives.
Yeah.
Remember we talked about personalized ads.
Mm-hmm.
Imagine advertising that's tailored to your interests and preferences, making it more relevant and less intrusive.
I'm thinking about the creative industries too, like artists and designers and filmmakers.
For sure.
VAR could be an incredibly powerful tool for them, almost like an extension of their imagination.
Absolutely.
Like imagine being able to generate concept art for a film or design a video game world with just a few prompts.
It would speed up the whole creative process and open up all these new avenues for artistic expression.
Absolutely. And even though we've explored all these exciting possibilities, we got to remember that VAR is still a relatively young technology.
Yeah.
What are some of the challenges or limitations that researchers are still working on?
Well, one area that's really active is improving the tokenizers.
Okay.
Those systems that convert images into those discrete representations that VAR can work with.
Right.
There's still room for improvement in terms of efficiency and accuracy.
Yeah.
And, better tokenizers would lead to higher quality, more detailed images.
It's like sharpening the tools to create even finer masterpieces. So as we wrap up this deep dive into VAR, I'm left with this one kind of lingering thought. If this technology can already do so much, what other groundbreaking applications might we see as VAR keeps evolving?
It's a great question. We've really only just scratched the surface of what's possible with visual autoregressive modeling. As the models get bigger and the algorithms get smarter, I think we can expect even more impressive and transformative applications in the years to come.
Well, there you have it, folks. A glimpse into the future of AI image generation. We've explored the inner workings of VAR, talked about its advantages over previous methods, and discussed its potential to revolutionize everything from advertising to art. So as always, thank you for joining us on this deep dive, and until next time, keep exploring and stay curious.